Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two questions from Probability and Statistics 1. And these two particular questions belong to paper 9709/53 for the session October-November 24. Let's read question number 3 of this paper. In Molimba, the heights in centimeter of adult males are normally distributed with mean 176 centimeter and standard deviation 4.8 centimeter. Find the probability that a randomly chosen adult male in Molimba has a height greater than 170 centimeter. Well, the question is very explicit that sorry, we will have to apply the normal distribution concept. So let's start our solution. X belongs to normal distribution and the parameters of normal distribution are mean as well as variance. What is the mean? Mean is given as 176 and variance is the square of standard deviation. So first parameter is mean 176 and variance is square of standard deviation, which is 4.8. Well, then they have told that a randomly chosen adult male in Molimba has a height greater than. So let us find the probability when x is greater than 170 centimeters. Then we will standardize the score. If we standardize the score, z greater than 170 minus mean is 176 over standard deviation, which is 4.8. If we divide z greater than, look at this, it must be negative because the first positive number is less than the negative number. So if we divide 6 by 4.8, it is going to be negative 1.25. Well, then we will have to draw the figure for this scenario. Suppose this one is our graph, okay? And our standard deviation, I mean z-score, is lying on the left side of mean line. Here 0, suppose here there is negative 1.2 is the z-score. So which part is our probability? Our probability is the right side, greater than z-score. So this part is our probability, okay? That means a greater part. So how can we find this probability? You know that the graph of the normal distribution graph is symmetrical. So what we can do, if I draw one more figure, here it is 0 and on the right side, if we swipe the z-score on the right side, it is going to be 1.2. So as we require the greater part as our probability, look, it must be as same as this. Look at this. We require the right side of the first graph, which must be symmetrical and similar to the left side of the second graph. Look carefully, you will find that this is exactly same because the graph is symmetrical. So if we take the left side of the second graph, it must be equal to the right side of the second one. That means larger part or larger region of the graph is our probability, okay? It's exactly same. Well, so what we can write is probability of z less than 1.25. Now you may tell that what is the necessity of going through these difficulties. Actually, there is no probability given in the probability distribution table for any corresponding negative z-score. So all the z-score given in the probability distribution table is surely positive. That's why we have swiped from left side to right side so that we get the positive z-score, and every probability is given for corresponding positive z-score. Well, so our z-score is 1.25. Let us find the probability for this corresponding z-score. Well, so we are going to find the, let us have the, well, our z score was this is the lower part, not this one. Our z score was 1.25. Well, let's have a look at our z score. Our z score was 1.25. So this is 1.2. This is our row, and column is 5. So it is actually here. This one is our corresponding probability. So our probability is 0.8944. Let us substitute this value 0.8944 equal to point 894 if we round it up to three significant figures. So that is what our probability should be. That's all about the first part of the question, first part of the solution. Well, the next question says, yes, this is what the next question is. 60% of adult males in Molimba have height between 170 centimeter and k centimeter, where k is greater than 170. Find the value of k, giving you answer correct to one decimal place. Well, so we are still under the same normal distribution, and our x belongs to normal distribution. Mean value was 176, and standard deviation, I mean variance, second parameter was 4.8 square. We are reutilizing the same information because still we are under the same distribution. Well, then they have told to find the probability of 170 between 170 and k. Okay, so it is more than 170 but less than, sorry, but less than k, less than k, and the probability is given. Probability is 60%, means 0.60. Well, now we will standardize our score. If we standardize our score, it is going to be probability of 170 minus mean value is 176 over standard deviation, which is 4.8, less than z, less than k minus the mean value. Mean value is 176 and the standard deviation is 4.8. Probability is 0.60. Well, then first z-score must be negative because positive value is less. So if we divide, in the previous one we have used the same z-score, that is 170, I mean 6 divided by 4.8. So it is going to be negative 1.25. Already we have used in the previous solution. Less than z and less than k minus 176 over 4.8. Okay, equal to 0.60. Well, now we'll have to see the scenario, what it actually indicates. Look at this. They have told that our probability is zero point 0.6. This is the clue of this question. Look at this. Our probability is zero point 0.6. That means it's more than half. So what is it actually indicates? Suppose this is our graph. Okay, from this graph, here our z-score is negative 1.25 and another one is k minus 176, suppose here. Okay, and another one is here 176 over 4.8, and this is 0. Okay, so which part is our probability? Our probability is actually this. Okay, this is our probability. And how did we understand that it should be on the other side, on two sides of the mean line? We have understood because the probability is zero point 0.6, it's more than half, so it cannot be any side of absolute side of the mean value, as our this probability is zero point 0.6. So how can we find this probability this in between these two lines? It is, let me draw another graph. So what we will do, we will just suppose here there is k minus 178 over 4.8, yes, 0, and here minus 1.25, 1.25. Well, so for this middle portion is our, look at this, the middle portion is our probability required. So what will we do? From whole of the probability we will subtract, that means this portion should be subtracted, this black portion, this portion should be subtracted from this portion should be subtracted from how much? From whole of this. Look at this. If we find the probability of this portion when z-score is k minus 176, then from that if we subtract this tiny part, okay, yes, this portion from whole of this, look at the left side, we will take the probability of whole of this, from which we will just subtract this black part. Look at this, the from the blue part we will subtract the black part from whole blue part. That means we will take the whole of the probability when z-score is k minus 178 over 4.8, from which if we take the probability whole of this for corresponding z-score, then if we subtract this tiny black part, then we will get the region in between them. I think you got my point. So what will we do? First of all, we will have to take the probability of this portion, then we will subtract when the z-score is minus 1.25. I think you have got my point. We will just write over here, or or probability of when z-score is less than k minus 176 over 4.8, from which we will subtract the tiny part when z-score is negative 1.25. So we will subtract when z-score is less than negative 1.25, 1.2 as well as 5, 1.25, 25. We will just subtract this, and our total probability is 0.60. I think you have understood this step. Once again I am showing, we are going to get the probability when the z-score is k minus 1.78, from which if we subtract that tiny part of when z-score is negative 1.25. Well, then probability of, okay, now once again, sorry, if we want the probability of this tiny part, look at this. For this tiny part, we require this portion. This is our necessity to be obtained. So for this, what will we do? We will swipe. This is negative 1.25, negative 1.25, and here 0. If we swipe to the right side, it is 1.25, because you have already come to know that there is no probability given for any negative z-score. So this part, this tiny part on the right side as well as on the left side of z-score must be equal. These two parts are equal definitely, because the graph is symmetrical. The normal distribution graph is always symmetrical. So these two parts must be equal. So instead of negative value, we will find the corresponding z-score for positive 1.25. So let us write here probability of z less than k minus 176 over 4.8 minus, look at this, when probability was this, in the previous case we have done also, it is 1 minus from whole of the probability. If we subtract the left part, we will get our tiny part. Okay, so for these tiny parts, what will we do? From 1, suppose, let me now shade whole of this. Look at this, we require the right side. Okay, so if we subtract the left part, yes, from here, when z score is our 1.25, then from 1, if we subtract the left part, we will get this tiny right part. So it is 1 plus, that is minus and minus, it is going to be plus, plus probability of z less than, because that we don't have any probability given in the probability distribution table for any corresponding negative z score. It is 1.25. 1.25, right side is equal to 0.60. Well, then let us leave the left side unchanged. Before that, I will have to write just beside this. Yes. Or probability of z less than k minus 176, k minus 176 over 4.8, then minus 1 plus 1 can be transposed to the other side, I think. If we transpose 1 to the other side, it is going to be plus of 1.6. Okay, then plus probability when our z score is 1.25. Already we have found the probability when z score is 1.25. Look at this. In the previous solution, we have got when z score is 0.125, our probability is 0.8944. So let us write 0.8944. 0.8944 point plus 0.8944 is equal to, if we add up 1 to 0.6, it is going to be 1.60. Well, let us zoom in. Yes. Then, or probability of z less than k minus 176 over 4.8. 4.8 equal to, from 1.6, if we subtract 0.8944, we will get, let us calculate, 1.60, 1.60 minus 56 is our probability, 0.7056. Let me zoom out again. It is point 0.7056. So this is our probability. Okay, so for this probability we will find the corresponding z score. Okay, let us write probability of z less than 4.8 is the denominator. Sorry, we don't write this. We are going to find corresponding z score for this probability. Okay, let us find the probabilities. 0.7056. 0.7056. For this we will find our normal distribution table. Normal, yes, we have not forgotten that our probability was 0.7056. So we will try to reach the closest quantity, 0.7056. Here, look at this, 0.7055 is over here. So we require 0.7056. If we add up 2 is not available, but at least that means the closest value of this is this 2. So what is the column? Column, first row is 0.5, then first column is 4 and second column is 1. So it is going to be, if we write this way, it is going to be 0.541. It is going to be 0.541 for the closest corresponding probability. So our z score is 0.541. 0.541. So let us write 0.541. 0.541 is equal to, probability is 0.7056. 0.7056. 0.7056. Okay, now if we look at the question, we can write here, look at this, both of them are z score. So surely this z score, I mean this portion must be equal to this one, because both of them are our z score. So k minus 176 over 48. Hence we can write, let me find a space to write this. I think we can continue writing over here. Yes, the final part of the solution. Hence, let us write hence k minus 176 k minus 176 over 4.8 is equal to what have we got? Our exact is 0.541. 0.541. We require k to be obtained. Hence, k is equal to, first of all, we'll have to multiply 4.8 into 0.541 plus, from the left side if we transpose 176, it is going to be plus symbol, it is 176, 1 7 as well as 6. So finally if we calculate this 4.8 into 0.541 plus 176, so finally our k is going to be, let us calculate using our calculator. 4.8 into 4.8. Our value of k is 170, 176 point, sorry, 78, 178.6. So this is what the final value of k, and that is how we can do the solution stepwise. And I think you have understood it well. Let us verify the answer whether we have written it correctly or not. It is 178.6. Yes. So that's all about the solution to question number 3. Let's move on to question number 4. Well, the next question is, yes, it's over here, and it says, on a certain day, the heights of 150 sunflower plants grown by children at a local school are measured, correct to the nearest centimeter. These heights are summarized in the following table. Well, draw a cumulative frequency graph to illustrate the data. Okay, we are going to draw a cumulative frequency graph. For cumulative frequency graph, look at this, continuity correction should be done, because if you look at this, look, upper bound of the first class is not the lower bound of the next class. So we will have to do continuity correction. So first upper bound, here you can write upper bound, upper bound is here. If we do continuity correction, it is 19.5, 19.5. Then it is going to be 29.5, 29.5, then 39.5, 39 point, I think I can write the whole class. Okay, so we can start. Let me write the whole of the class width. Let me draw one more table, or in the given table we can write. Okay, I think in the given table if we write, it will be lower bound will be 9.5, 9.5 until 19.5. No, this place is not sufficient, then I will have to zoom out more. No, it cannot be continued there, so one more table should be drawn. Let us draw another table just over there. Okay, so first class bound is 9 point, lower bound is 9.5 until 19.5. Then the second class will be 19.5 until 29.5, 29.5, 29.5. Then third class will be 29.5 until 29.5 until 39.5, 39.5. The next class is 39.5 until 44.5, 39.5, 39.5 until 44.5, then 44.5 until 49.5, 49.5, then 49.5, 49.5, 49.5 until 54.5, 54.5, and finally it is going to be 44.5 until 59.5. 54.5 until 59.5, 59.5. Okay, then we are going to write the cumulative frequency. Okay, first frequency was, how much was the first frequency? It was 10. So it is 10. This was class bound, and this is frequency, cumulative frequency. Okay, cumulative frequency is 10. Then 10 plus 18, 28. Second one. Third one is 28 plus 32. It is going to be 60. Then 60 plus 42, 102. 102, 102. Then 102 plus 28, 130. 130 is the cumulative frequency. Then 130 plus 14, 144, 141, 44, and 150. So this is what our class bound and frequency is. So let us write it is 9.5. So let us write here 0, then 1, 2, 3. So our range is how much? From 9.5 until 59.5. So 60, we require 60. I think we can write from here. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is 10. We can write here 10. This is 10. There should not be any point because here is 10. Then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There will be 20 over here. 20. Then 21, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 30 is over here. 30. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 40 is over here. 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 50 is over here, and 50 is over here. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 60 is over here. Okay. Well, then the frequency, minimum frequency is what? It will be 150. Okay, so for 150, let us see whether we do have 150 or not. I think we do have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is 10. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is over here. This is 10. Then let me write rest of them. Considering each square as 2 units, we can write here 20, 20, 40, 60, 60, then 80, 80, 100, 100, then 120, 140, 140 as well as 160. 160 because our total frequency is 150. So 150 should be there. Well, now we are going to plot the points. So first one, if we look at our class bound from 9.5 until 19.5. So lowest point is our 9.5. Let us mark 9.5. So 9.5 is, what is our 9.5? Here is 9.5. Okay, when 9.5 it is 0. This one. This is the, let me use different ink. Yes, this is 9.5. Okay, then when our upper bound is 19.5, then our frequency, cumulative frequency is 10. 19.5, where is 19.5? This is 19.5 and 10 is, look at this, this is 10 and 19.5. So it is going to be over here, this one, 19.5, 20, then it is going to be for 10 here. After that, the our upper class bound is, we are just writing the upper class bound. Okay, upper class bound is 29.5, cumulative frequency is 28. So 29.5 and 28. So it is 20 over here, 30. 29.5 is over here. Okay, and our cumulative frequency for 29, it's 28. So 28 is, 30 is over here and 28 is, if this is 30, so 28 is over here. Okay, that means just 4, and it is 29.5. So 29.5 is just over here. 29.5, yes, 29.5 and 28 over here. The next cumulative frequency is 60. Okay, so our 60 is over here, and surely our upper class bound is 39 point, the upper class bound is what, 29.5, then 39, upper class bound was 39.5. So 39.5, it is 60, frequency is 60. So 39.5, 60 is over here. So this will be our points, 60 and 39.5 over here. Then after 60, next frequency 102. So 102, 102. For that, our upper class bound is 39.5 has gone away. So 44.5. 44.5, 44.5, it is 102. Okay, 44.5 and 102. Okay, so 44.5, just 45, and 102, 100, just one, it will be over here. 44.5, half of this, it will be over here. After that, the next frequency community frequency 130, and upper bound is 49.5. So 49.5 and 130. 49.5. So it is 50 and just 49.5 and 130. 30 will be over here and 49.5 just over here. Just 30. Okay. So over here. Then after 30, 144. So 144 and our upper bound is 54.5. Okay. 144 over here, that just two steps up over here, two steps 144, then it is going to be over here. Well, then finally our upper bound is 59.5 and our frequency is 50, 150. So 59.5, it was 60 there, so 59.5 will be just and 150 is half of this, so over here. Then we will have to just connect these points. If we connect the points, it will look like, I'm trying my best to connect the point. It may not look good. Yes, that's how we can connect the points. Okay, so the next question says that use your graph to estimate the 30th percentile. So first of all, 30th percentile is equal to 30th percentile. Let it be written 30th percentile. 30, 30th. 30th percentile. 30th percentile equal to. So 30th percentile is 30. Total it was what? 150. 150 over 100. Okay. Equal to it is how much? 45th, maybe 0 0, yes, 45th data. So let us find the 45th is this. We couldn't connect it well, it should undergo this through this point. Okay, 45th data, let us find 40. So 45th data is over here, 40 to 60, so it will be over here. So over here, how much is this? It will be 36. 36. So it is 36. The figure, I mean graph, may not look like exact, but it is. Well, and it is 40. How much? 45th data. 45th will be just over here. Well, that is what the solution, the first part of this question. After that, we will have to move on to the next question. Next question says, calculate estimates for the mean and the standard deviation of the heights of 150 sunflower plants. So first of all, we will have to find the mean. Then mean is equal to mean. Mean is, sum of fi xi over n. N is total 150, and if we multiply fi xi, we'll have to go back to the previous page. Yes, this was the previous page. And here first, as this is class width given, so we will find the midpoint. Midpoint of 10 and 19 is actually 29. So 29 is 14.5. 14.5 into 10, that is 145. First one is 145. 145. First one is 145. 145 plus, let's move on to the second one. Second class mid value is, second mid value is 2229, that is 24.5. So 24.5 into 18. 24.5 into 18. 24.5 into 18. 24.5 into 18 plus the next class width. Next class width is, that is 3239. That is, it's 3239 means it's 69. So it is 34.5 into 32. 34.5 into 32. 34.5 into 32. 34.5 into 32. After that, there will be next class width is, it is 40 to 44, so 84. 84, half of 84 is 42, so 42 into 42. The next class is 42 into 42. 42 into 42 plus next class. Next class was 45 and 49. That is 94. Half of 94 is 47. 47 into 28. 47 into 28. 47 into 28. 47 into 28 plus next class width is 50, 54. So 104 means 57. 57 into 14. So 57 into 14. 57 into 14. 57 into 14. 57 into 14, and the final class we can write over here. The final class width was 55 and 59. So it is 114. Okay. 114. That means it is going to 57. 57 into 6. 57 into 6. 57 into 6. 57 into 6. Now we will calculate this using our calculator. Equal to, let us use our calculator. First one was 1 I think in this class, the just previous to the last class we made a mistake. It should not be 57. It will be 52. I think it will be 52. Look, this should not be 52. Sorry, it should not be 57. It will be 52 rather. So this is 52. So 52 into from, because both of them cannot be, midpoint cannot be 57. It must be less than that. So it will be 52. So let us rectify using our calculator. 52. The last one should be 52. 38.9 is our mean value. 38.9. 38.9. Then they have told us to find the standard deviation also. So standard deviation is equal to, standard deviation is square root of, that is all of these x values, mid values will be square. Okay, so if we erase the first one was 14.5 into 10. Okay, it was 14.5 into 10. 14.5 into 10. 14.5 into 10. So now everyone will be square. It will be, x values will be square. Okay, this will be square. Let us use different ink. So 14.5 square, then 24.5 square, then 34.5 square. Let us use them here. If we write here fi, this is fi sum of, sorry, it is sum of fi x squared, then over n, minus mean value sum of fi xi over n, then whole squared. Okay, so all the mid values will be squared. Now let us use our calculator to get the value. Okay, here all of the mid values will be square. So here this is equal to, 16 square root over 16. Let us have a look again. It is 1628.567. 1628.57 minus mean value. Already we have obtained our mean value was 38.9. So it is 38.9 square. 38.9 square. Okay. So finally our standard deviation is going to be, our standard deviation is going to be equal to, so square root over this one. If we use here square root symbol, no, to get more accurate answer, we will have to expand it. We have rounded it up to three significant figures. It was actually 38.93. So let us write 38.93 square. Okay, it is just a square equal to. So let us calculate once again. If we calculate, then we will get this one was 38, not 38.9. It should. It is 10.6 is the standard deviation, and already we have found our mean was 38.93. If we round it up to three significant figures, it is 38.9. And I believe that you have understood the solution. So let me show the previous part once again. This was the previous part. The graph may not look like so much eye soothing, yet this is the, I have just tried to clarify the method how to do this. Just here the point lies in continuity correction. You must find the class lower bound, upper bound of the previous one must be the lower bound of the next one. So continuity correction should be done here. And before that we have completed 2 is over here and there. This one was the question number 3, and this is first part of 4, and this is the final part of 4. That means finding mean as well as standard deviation. So thank you all for staying with me. May Allah bless us all with the beneficial knowledge. Allah Hafiz.